So you've probably done this, right? You have a string, or whatever data type. It's called S. And then what do you with the string? You put a string into the string. So new as we pass the address, right? We usually don't even pass the we need a pointer, but we just pass the address because we don't have a pointer variable right now. So it's convenient, right? Because we need the pointer if you want to modify the struct string in the function. And then actually I'll just use this one, hello world, right? Oh my gosh. And then if we print this, it's gonna work, right? Compile it. Oh, well, it's a struct, so just like std string, pass the data, hello world. So what's the problem here? Well, there's no problem actually if we just use functions, because functions are type safe. When we pass a I guess I'll new I know this. Okay, fine, determine cap 8, and I guess just so when we pass the address to the function, it will act as a pointer, and this, it's just fine. We can, inside this we have a dest, right? We actually have a variable, so we can access it, whatever, right? But that's functions. But if we are using macros, which if you're implementing a vector or a heap array, it's much easier to use macros because, unlike strings, you have different, like, so many different types of numbers. So you probably do something like, I guess let's just make a struct here. Where is it? This is usually a vector, right? Maybe I'll remove the... it's fine, right? You have a struct. You have a type, which is the type of the number containing the data, pointer to data, because it's a heap array. We have the size, we have the capacity, and then we have the name. And then I guess that's I guess let's declare it here, right? So let's vector type, let's say we want an int and then we have a vector. And so we probably don't want to manually manage the vector. That's the whole point, right? We don't have to we can know the size, we can know this capacity, we can just use functions to but in this case it's a macro. So let's do vector new, I guess, and then vec, And a nice thing, we don't actually need to care about the type of vector. So if we're working with int or double or whatever, we don't need to care about that. If you're using a function, you need multiple functions or some, you need to jump through the hoops to actually do some stuff with it. But let's say we want to pass a capacity, and then we're gonna malloc the vector, right? And let's say we want to do it like a function. We want it to act like a function, right? Also, don't forget do while, because if you it can screw up stuff if you forgot to do a do while, and then, for example, you have like multiple semicolons, and you have it on an if, and then the else doesn't work if the if is not surrounded with braces. But so yeah, but we have a vector macro, right? So, well, actually we should probably make an init macro, right? Vec init vec vec dot, or I don't know, I guess we can make it we can access with arrows, because I don't know, maybe we won't want to do that. Actually you probably need to actually no, well, if you're using it in a function, you probably need an arrow, right? So vector data 0, or I guess we can even do this, right? Vector, actually null, the same thing. Vector size 0, vector capacity. And this actually might not work, actually. Let's see. I think this actually might not work. Well, no. This will work fine. Vec init, and then pass the vec. Or I guess no. We have to actually make an instance of vector. Vec v, and like functions will we'll just pass the v, right? And then as you can see, it doesn't work. So it doesn't actually work. Nice. So if we actually try to look at what the macro is doing, in place of as it replaces ampersand v into vec init, right? We can see that with gcc -e. It's a really nice thing, because usually it's a nightmare to debug macros, but yeah, as you can see, it doesn't work. Why? Because as always, it's always the operator precedence. As you can see, ampersand here conflicts with arrow. If we see the operator precedence, I think arrow is more it has higher precedence, and so this actually means this. And that doesn't really make any sense, because v is not a pointer to struct. V is an instance of struct, and then we're trying to access it with an arrow operator, and without proper parenthesizing in the macro, because in the macro we just assume that it is like v size. We assume that it's like a function. It's just gonna work. Well, it doesn't, because operator precedence, as always, it's a pretty annoying thing. But what we want is this. As you can see, this actually works, because what this does is we pass the address, and then it can actually access it with an arrow. It's like I guess it's like as though, as in the function, we actually have an variable, right? A pointer to struct. So like jstir init t, and then like p, and then right, or is undeclared identifier p. Okay, but you know what I'm saying, right? Actually, let me. I don't know, but you get the point, right? So if we in a function, the address is going to be converted to the pointer, so we don't need to worry about the operator precedence, because it's not a simple text replacement like in macros. In macros, as you can see, it merely replaces the parameter. Well, it doesn't even replace the parameter. I mean, it just uses anything it gets, and then it copy pastes the macro with the parameter, and so we get this. And as you can see, this is the most this is the most simple I guess thing, right? We're not even doing anything. We're just initializing the vector, right? But it doesn't actually work. So to make that work, well, what's the problem? Well, the problem is operator precedence. If we use the macro here, this is gonna be replaced with, as we have seen before, with ampersand v, and then ampersand v actually means v data, which doesn't make any sense, because v is an instance of a vector, but it is accessed with an arrow, which if we try to access with an arrow, well, I guess arrow is the same as, I forgot, but arrow and dot is just the same, right? Just syntactic sugar. But if we need to access the struct, or if we have the struct directly, right, since this is a macro, it doesn't make sense to use an arrow operator, because the arrow operator is going to dereference the fee, right? I think arrow, let's see, arrow, I forgot the exact, where is, yeah, arrow is equivalent to, it's gonna dereference vector, which if we have a pointer, it's fine, but we don't. We try to dereference v. We try to dereference an instance of a vector, and then get the member, which doesn't make any sense, because you use arrows with pointers. and dot with actually non, I guess, structs, I guess. But as you can see, you need to carefully parenthesize. So if you're doing something like this, don't just don't just do it like this with like macro. Well, do it with macros, but don't do not parenthesize the uh I don't know, variables, I guess. Also, you don't need to do this actually. You can make it work like functions, when you pass something to a function, the function actually has a copy of that thing which you are passing, and you can kind of make a macro work like a function. You just make a temporary variable. So, well, you just make type of, which is the thing you can use when you want to work with. So, well, I guess let's just do this, right? Type of v, right? V is a vector, right? Type of v, let's say array, and it's actually a vector because it just copies the type, right? It's a type of v, which is vec. So what we can do in a function is, well, not in function, in a macro, is just like a function, right? We just make copies of the things we're passing, or in this case, maybe not even copies, just the copy we need to be type safe, or we need to be not at least processed at a I lost my train of thought. It's like process, because if we're just doing macros, the preprocessor is going to just take whatever we pass to the as the parameter, and then it's just going to, if we pass the address, in this case we're not using a pointer, right? It's just going to write whatever we pass, so like ampersand v. But if we declare a variable, so like type of vec, and then tmp vec, also don't forget to parenthesize. Maybe there will be some problem if you don't parenthesize. So just in case, just parenthesize, because you never know, right? So as you can see, we don't actually do anything except just making a temporary variable, right? So actually, let's remove this, right? Make it unsafe, and then change vec to tmp, and then it's magic. It works now. Why? Because, well, tmp, this will expand to this, right? So we're passing the wait, does that make sense? Don't I need to dereference this? I'm actually not sure. Oh no, wait. No, it's actually because we're passing an address, which is a pointer. So what tmp is, wait, wait a minute. Do I need to dereference this or something? Oh no, I forgot. Oh, I just okay. This is double ampersand because I'm just but you know we have an address, right? So it's an address. This is an address, and then what are pointers, right? Pointers are something that points to something, and then you get that with the address, and then, it's like the same type, but what we actually have here is a type safe. Well, uh, it's an actual pointer, not just the address. And so when we do like we access the data, we access the size, we access the capacity, right? It's fine. So if we print, right? Print the I don't know. Let's just print the capacity, size and capacity, or whatever. Yeah, I'll do both, I guess. So why not? So is everything fine? No. Oh shit. Second function call is an uninitialized value. Wait, what? Array size, capacity. Have we vec in it? We have. Oh, it's an array. It's the new. Okay, it's not the thing we have passed to initialize. Okay. It's fine. It actually works. So if we change this to 9 or whatever, it works, right? So that's just it, right? If you're making, well, you have two ways to deal with this. If you just want to be safe, you should make a temporary variable. That way you don't need to worry if the macro, if this is just one macro, right? If you have multiple macros that uses other macros, it's gonna expand to some, like, this is just the V, right? If we have other macros, it's gonna dereference, it's gonna do all sorts of stuff, and you might at one macro or something, you might do something wrong, and by having type of here, by declaring a temporary variable to hold the address so it's an actual pointer, it's more safe. So you can do that, or you can parenthesize everything, right? But also, if you're iterating for some reason, iterating the vector, this, like, this is gonna be dangerous, right? Vector dot date size. So if you have a pushback, right? Let's make a pushback, right? Because we haven't really made anything right now. So vec element, right? So vec, what do you do with a pushback? Well, just access vec, right? Access the data, and then get the current size, not capacity, the part of the vector that has elements in it, not just undefined or uninitialized elements. So vec.size, and then let's say, well, we can do this, right? Vec.size, and as you can or this is more if well, I guess a pushback will not do this, but let's just, vec something. So let's say we want this, right? It looks fine, right? It's gonna go to the well, it doesn't look fine, but whatever. For some reason, you're trying to iterate over the size, and as you can see, if we try to actually pass, vector into it with an address, one, I guess it's an error. You can't do this because, well, I guess let's just check the expanded thing. We're actually iterating over the address, so yeah. Also, there is what was it that I wanted to talk about? Oh yeah, you can also not make the temporary variable. You can assert that the user is not going to pass an address. So you will assert that, or you make this in your documentation, that you shall not pass an address to the macro. And we can actually check that. So there's we can check that at compile time with static assert. So it's a new feature, but actually it's static assert in, I don't actually know which one is the, I think it's static assert in C, but we it's like an assert, but at compile time. But we can, if you've used macros, you can actually, well, I guess let's try this, right? Stringy size, or I don't know. Stringify string. So you can actually do this, and what this does is, let's just pass something to it, right? Stringify. Okay, what does that do? If we check the GCC E, it's gonna turn what you, so we pass an S, right? Just a regular S, but it turns that into a literal S at compile time. It's gonna convert that into literal S. So, and why I'm talking about this, you can do that to check if your user is passing a an address. How? Well, we just, with strings, well, how do you print strings, right? You iterate over the characters. So you can just take the first character of address v. So also, I didn't know this before, but apparently you can do something like hello world. Wait, no, I guess let's make this. You can do this. So you can have a literal string here, and then you can just, just like a like an array, right? And then it will print. Let me fix this, right? It's a bunch of errors. It will print the first character. So how do we implement? How can we make that useful? Well, we'll just add this thing to well, we can just make an if, right? Because I don't know. So if vec, so we change address v, we change whatever we're passing to vec init, right? We change that. Well, we're not gonna change that, but we at this if, we're going to stringify it, as seen here, and then we're gonna take the first element, which is the address. So what we can do is just compare it with an AND. If it is not AND, or I guess more simply, if it is AND, return or abort, whatever you prefer. But what's happening again? Use of undeclared TMP. Oh yeah. Gosh dang it, man. So TMP vec. Oh my gosh. TMP vec. Okay, thank you. Well, it's not gonna run, but if you still don't trust that that there will be no errors concerning operator precedence, you can do that, and then I'm pretty sure it's going to let's I guess do a printf here, right? Printf or fprintf to the standard error print illegal input also, always put your macros in a do while except it's ternary or something. So we've passed the address v, right? So if we try to run the program, we can't. Well, we're early returning. So if you're making library or something, and your user didn't read the documentation and still passed an address, well, he will get a warning. Or a better way to do this is just, if you really don't want your users or your whatever to use an address, we can do a static assert, and it's not even going to compile. Wait, static assertion. Expression in static assertion is not constant. Wait, is that true? I've always... Wait, really? Huh. I thought that was constant because... Static assert with no... Well, you know. I guess it doesn't work with static assert. Okay, I learn everything every day. But, well, it's not even gonna compile because of the wrong reason here. But, if you have a normal assert, I guess. Assert .h. Why is it undeclared? Oh, we have a string here. Is not. Right? It's gonna assert that it is not. It doesn't start with an address, and so it's gonna return early. So, and it's pretty clear, right? What this is, which is it's gonna take the first or 0th index and then compare it to this, which it is equal to. So those are ways you can avoid screwing up your macros, getting undefined behavior. You can either play safe with temporary variable just. You can think of it just like functions. It's how functions work. I don't know. But yeah. So you can either play safe with a temporary variable or just parenthesize literally everything concerning that parameter, macro parameter,